Hello everyone, my name is Emran Baiti and I'm an environment artist, and in this video I'm going to show you guys a simple door blueprint that can be locked and unlocked and be opened and closed. So I just wanted to have this idea of having control over opening and closing and locking and unlocking the door. So I'm going to show you guys how you can do it on a small quick video tutorial, so you can set it up on your own. First of all, what you need to do is you need to make sure that your door is, or whatever you're doing, need to be separated. So basically in this door the frame is separated, the doors are separated, and the locks are also separated, and this engine and this electric motor is also separated. So you need to first make sure that your meshes are all separated, so you can set them up and like access into each individual module to, you know, rotate or even move or anything you want to do. So and you need to, you know, somehow know some basics of Unreal and its blueprints system to make sure like how it works. So first of all, you need to create the blueprint class. Make sure it's actor. Just give it a name. Let's call it 01. So when you open it, it's all empty, and there's no wonder for that, because it's just a simple empty blueprint. So we need to bring our modules in so we can access in you know, every individual parts to be rotated or whatever you want to we want to do. So first of all, we want to have the frame. So let's search for the frame. So this is the frame. We need to bring it inside the blueprint. So as long as we as soon as we bring it, it'll pop up, but it's been placed at the mid ground, so we need to select it and bring it up. We need to make sure it's touching the ground, so we can go to the front view and bring it up until it meets the ground. So next we need to bring our each door sides. So we can open our content browser again. We have two doors. This one is the right one, this one is the left one. We can start with the right one, bring the whole thing in. So we need to make sure that the door is going to be placed in its place. So first we can like bring it up, go to the front view again, bring it up, and then we can go to the top view, and we can bring it here. We can go to the top view, and we need to make sure that it's been placed on its original place. Okay, now it needs to become a bit higher. Now just to see how the rotation works, we can just select it, select the door, go to the rotate mode, and then try to rotate it to see how it works, which works fine. We need to do the same for the other side. We will bring the other one. This is the left. For some reason it's been rotated. Don't worry, we just need to reset the rotation. And since they both are, and they pivot, they both of the pivots are in the same position, we can just select the one that we just located, copy its location, select the other one and paste the location, and it's right there. We just need to bring it back. and we can go to the top view again. To make sure that the location looks okay. So we can try to rotate it and it looks fine. Okay, the next step is to put our lux system in place. So it's been composed from an electrical motor, a pinion part on top of it, the lug itself, and the lug frame. So we can go back again, bring our content browser, start with the lug frame. So just for the sake of making this video short, I will do a time lapse, and once my placement is done, we'll back and talk again. Okay, so one thing to keep in mind is we need to make sure that all of our modules are using a proper hierarchy and a proper child actor. So basically what I mean is, when we want to rotate the door, we want to make sure that the engine, the lug, and all of its dependencies needs to rotate it with itself. So how it works, we need to make sure that we place all of the child actors to be the sub hierarchy of this door. So we need to select the modules, which is the electrical motor, the pinion, the lug, and the lug frame. All of them needs to be under the entrance door left. So basically these guys are the child actor of this actor. So it's the other one, right one. So when we select this and when we rotate the door, as you can see, the rotation for all of the child actors and the main actor works fine. We need to do this for the other lug part as well. So basically what we need to do now is set up the logic in the construction script here. All of the logical parts, like what each part needs to do, happens in this part. So first thing first, we want to rotate this door separately and then rotate this door separately. So how can we access to this door? If you could manage to set up all of the actor and its child actor properly, they should rotate using the rotate tool fine. Since we have this under our default scene root as actors, we can access these actors using this construction script. So how it works is, we can start with the right door, we can select our mesh and then bring it here. So this is our actor, and from here we can use our construction script. And then one of the things that I really like about Blueprint is that it comes with this really nice suggestions for what type of node and what type of tools you can use with each type of actor, and then it's really handy. So basically what we need to do is to rotate our door along the z-axis. So if this is the z-axis, we want to be we want this door to be rotated along the z-axis like this. So we can bring this guy here and then type like add local rotation. So what this node does is basically it will get a value based on each axis, and then it will rotate your actor based on these values. So we need to make sure that our execute works. We want to make sure that our target is our entrance door right, which is this guy. Sorry, right is this one. We need to set up a variable to make sure that we can have access to each individual axis, but in this case we want to access for the z only. So we can start creating our variables here. We want our variable type to be float. We can name it properly. We can start saying like right door rotation. We need to we need to compile it to have the default value presenting, and then also we need to make sure that we have checked this eyeball to make sure that we can edit it later on in the editor. So we will bring our variable in. We want to get the value from this guy, and then from here we can make a rotator, and then here we can tell this make rotator that how we want to use this variable in this make rotator. Since we want to rotate our door along the z-axis, so we want only the z-axis to be rotated, and then we want x and y to be 0 because we don't want those axes to be rotated. So we will connect this guy here just for the sake of see if it works. Let's compile and save and go back, select our main root here. We have our variable presenting here, and let's see if it works. As you can see, it works. It's just rotating along a wrong value. So what we need to do is make sure we minus this using a multiply. So we need to multiply this guy with -1, so it will rotate along the along its correct axis. We also want to make sure that our slider range is from 0 to 140. Let's see if it works. Okay, it works fine. Now, if you want to know why we have set a slider range, is because logically the door shouldn't go inwards. It only needs to be open from the outside. So it needs to be rotated from 0 all the way down to 140. And if you set a value more than 140, then it will like hit the frame. So 140 is a good value point. We need to do the same for the other door side. So it's pretty simple. Same thing happened just for the other actor, which is SM entrance door left. We need to select these nodes, paste it. We need to make sure that our construction execute is connected. We need to make sure that this one is the left one, since we want to rotate the left door, not the right door. Now we also need another variable to be accessed for the left door itself, not for the right door. So we can select our variable, duplicate, rename it to left. Now we can connect this guy back here, delete one, and then let's compile to see what we have. Now we have the left door rotation. Now it's rotating inwards, and the reason why is we have this minus setup here, since this one needed this minus setup, but here we don't need it, so we can get rid of it. We can connect our float variable for the left rotation directly. So let's see. Now this one also works fine. Okay. Okay, now it's time to rotate this pinion part here. Let's start do its construction. Okay, so we need to first access to its mesh itself, which is this guy. If we go back to the viewport, we can see that this guy is selected. We go back to our construction script, we bring our actor in. Now we want this guy to be rotated just like our door, but this time we want it to be rotated all the way 360. So same add local rotation, same actor. Now let's set up another variable to be accessed for this actor. We can start just duplicating this one, rename it to right lock. Let's make sure it's the right one. Yes, it's the right door. Okay, now we can bring this guy here, get our float value. Now let's just create a rotator and then connect it to the z-axis directly to see what happens. If we come here, we can see we have another variable here which works fine, but if we remember, we have set a slider range. We don't want this slider range for now. I just want to show you guys what's the proper setup for this one. So you can see it's start moving, but since it's a float value, it takes quite a lot to rotate properly. But what we want smaller value here, but we want full rotation. So how can we achieve that? It's pretty simple. Let's make this guy 0. Let's bring a multiply. Now we want this guy to be multiplied by 360. Now if it's 0, there's no degree. If it's 1, it's multiplied by 360. If it's 2, it's multiplied by 360 again. So let's see how this one works. Now let's set a slider range like 0 to 3. So basically 3 means 3 times by 360. Now let's see what we have. Now we can see that we have smaller number, but at each one complete float value we have 1 360 rotation. So 0.5 will be 90 degrees, 0.5 is 180, and then 0.75 is 270 degree, and 1 is complete 360. Now our rotation looks fine. Now we need to come up with a solution to make sure that this guy moves forward based on each complete rotation. So basically when we have a complete rotation for this part, we want to be we want this part to be pushed forward at the exact same and correct value. Now how can we achieve that? We just need to know our circumference of our part. Basically this is my mesh, the very same mesh that I have been used in Blueprint. Now if we have measured it properly, its diameter is 10 and its radius is 5. So based on just a simple calculation, we can realize that a circumference of a circle with a 5 centimeter radius is 31.42 centimeters. So basically with a complete rotation, this guy should be moved forward by 31.42 centimeter. So let's go back to our construction script. Let's bring this guy, multiply, .42. So basically if this is 1, it's been moved forward 31.42. If it's 2, it's double, and if it's 3, it's triple. Now let's see if it works. Now what should we do with this one? We want this part to be pushed forward. So what we need is just a local offset. So let's find its mesh. First let's bring it back all the way down and make sure that it's been placed in its correct location. Its name is SM entrance door lock. It's been selected, we just need to bring it here. We will look forward to add local offset. We want to make sure our execute is connected. Now we want this guy to, we want this value to be used to push this actor forward along y-axis, since this is y. Okay, so what we need is to, since this is a float value and location is vector value, we need to make sure that we have connect this value to be affected only on y. So in this case we will going to need a make vector. Now this guy needs to be connected to the y, and for the x and z it needs to be set to 0 because we don't want those axes to be moved. We only want the y-axis to be moved by this value. Okay, let's connect this guy. Let's compile and see if it works. It works just like a charm. The only problem is it needs the value for this guy needs to be inverted. So same thing here. Now it works fine. The other problem is we need to set a limitation for how far this thing goes forward. I think 1.35 could work. Okay, we will select this guy, which is our main value for our right lock system. The slider range needs to be 0 to 1.35. Okay, the only thing we need to do now is just do this very same thing for this one. So it's pretty simple. We will select all the way from here. Copy and then paste it here. We want to make sure our construction execute is connected, and we also want to make sure that our proper actor is been selected. So this one is SM entrance door pinion, which was for the right one, and if we go for the pinion one, this one is basically for the left one. We'll bring it here. We make sure it's connected to its correct actor. Same goes for this one. Door lock 1. Okay, the other thing we want to make sure is correct is our left lock variable. This one is for the right one, so we need to select this, duplicate, and rename it to left. Get correct value, and let's see if it works. So now we have two float values, one for the right lock and one for the left lock. Work properly. Now let's bring it inside the engine. Okay. Right door opens, left door opens, right lock system and left lock system. They both works. Now you might ask yourself, like, why an environment artist need something like this to be set up, because it might looks like something that is a part of gameplay in a game. But the thing is, imagine that you want to use this door like a couple of times in your environments, like one is open, one is closed, one is like half closed. In that case, you need to like have multiply static meshes imported from your 3D package. But having something like this set up in Unreal gives you this ability to like procedurally place and use it however you want it inside your environment. Hope this finds you helpful, and please let me know if you have any questions in the comments. Cheers.